Hello friends, welcome to lecture number 1 of Boolean Algebra, and this is going to be introduction video of this course. And we're going to start with the basic things. What are the operations of Boolean Algebra? What is Boolean Algebra? What does it deal with? Okay, so this course was requested by one of my subscriber, and she is from Kumau University. Her name is Sneha Tamata. And before we start, let me tell you one more thing. If you want to request me any create any contents on any course of physics on any topics, any particular topics that you want help, then just you can send a message. This is my Insta ID. Look at it. 123. This is my Insta ID, so you can message me. Okay, so now let's start. Now you see Boolean algebra. Also, you can say it is binary algebra. Okay, so because it deals with only variables having two values only, and those are 0 and 1. So we can represent 1 as true and 0 as false. Okay, we can say that way also. So now here you see, which can also define as true and false as well, right? So 1 is taken as true and 0 is taken as false, right? So basic operations that we're gonna get here are this, or which can be represented by plus sign. Okay, and AND gate, here we get AND operation. So simply you can say product, and NOT operation, that's gonna be complementation. Okay, right? So now you see, let us talk about OR gate. Let's talk about OR operation. Okay, let me go to the new slide. So OR is binary operation, which is also here you can see that referred as logical sum or union. You can say sum or union of variables. If we have two variables a and b, suppose, and are two logic variables we have, suppose a and b, and subjected to OR operation, then y be the suppose the result of that operation. Okay, then this operation then can be written as y is equal to a plus b. Here y is 1 true if any one of these two is equal to 1, either a or b or both. In all the three cases it is equal to 1. Now let me draw the truth table for this operation. Now you see, so a and b, y is equal to a plus b, that means OR operation. So when a and b both are 0, then only it can be 0. That means if a and b both are false, then the result will be false. Otherwise, if any one of either a or b, if any one of them is true, then the result will be also true. If both are true, then also true. So here you can see, here only a is equal to 1, so we are getting 1 here. Here b is only 1, so we are getting here 1. So here both are 1, then we are getting 1 here. Only in one condition, that when both are 0, then this is equal to 0. Now let us go to another operation. Let us discuss another operation, that is what? This is the truth table for the OR operation. So now let us discuss about AND operation. This is a binary operation. Okay, referred to you can say logical multiplication to as logic multiplication. You can say it as a product. Okay, or intersection, or you can say intersection. Let us consider two variables a and b as two logic variables. Let us take these two as logic variables, and y is their output. Suppose y is the result, okay, of these two variables when it is subjected to the operation AND, okay, when they are subjected to the operation AND, okay. Then y can be written as a dot b, means a into b, you can say product of a and b. So here you see the condition is such that this a will be equal, the output will be true, or you can say 1 if both the variables are true, okay. If both a and b are true, that means a is equal to 1 as well as b is also equal to 1. Only in that case y will be, that means the result gonna be 1, okay. And if any one of a and b is false, then the result gonna be false, okay. That means it's 0 or false, you can say, if any one of a and b are 0 or false. That means to be the result to be true or to be equal to 1 when both a and b, both variables are true or both are equal to 1. Otherwise the result gonna be false or 0, you can say that way. Now let me give you the truth table. So here is the truth table. Here you can see, let me take a and b as a variable. Here y is a dot b, that is the product of a and b. So here the condition is only when both are equal to 1, then the result is 1, okay. When both a and b equal to 1, then only the result is 1 or true. And in the remaining cases, when you will get both a and b false, then result gonna be false. If any one of them is false, then also result is false. So here you see, here a and b both false, so result is false, that means 0. If here 1 you see a is only 1, b is false, that means 0, so that's why here also result is 0. And here you can see a is false, b is true, that means b is 1, a is 0. Then also you have you're gonna have the output false, that means 0. Only in this condition, only in the last condition, you're gonna have the true result, okay. So hope you have understood this. Let me clean these things. And so here is this is the truth table, okay, truth table for the AND gate, AND operations, okay. So now let us discuss about NOT operation. This is unary operation. Here we're going to deal with only one variable, okay. So let me write the definition here. So, or you can say complementation, okay. If we have a variable a, it is any logic variable we have considered, then it complementation or not is given by y is equal to a bar. Here this bar represents not operation or complementation of a. So what does it mean? So y gonna be equal to true or 1 when a is false, okay. They are complementary. When a is false, then only output gonna be true. And if the variable a is true, then y gonna be false, okay. The output gonna be false when the variable is true, that is 1, right. So hope you have understood this. Now let me write the truth table. Here we have only one variable and one output. Here you can see a naught. So when a is 0, output is 1. When a is 1, output is 0. So this is the truth table for NOT gate, NOT operation, right. So this is the truth table for NOT operation, right. This is just an introductory video to binomial algebra. So we gonna learn lot in this course about binomial algebra. So it is just introductory video. We haven't discussed a lot here today, so just I have given the introduction what is binomial algebra is. So in the next video we're going to discuss about the binomial all the identities of binomial algebra. What are the identities we're going to use, what are the theorems we're going to use, okay. That going to be discussed in the next. So you can join me on Insta. This is my Insta ID, as I have already told you before. So see you in the next video. Thank you for watching. Stay connected and share with your friends, inspire me to create new contents for you and help me to grow my channel, and subscribe the channel, hit the bell icon so that you get notified when new video will be uploaded.